Dr. Ranjani Parthasarathi is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer networks. Today we will be looking at security related issues in the network. So, we will be looking at security protocols which are used in the internet. The topics that we will be looking at are as follows. So, we will look at transport layer security and we will look at network layer security. All these security protocols will be using some kind of cryptography based mechanisms. So, what we are looking at is how at the transport layer and at the network layer these are incorporated as part of the communication, as part of the protocol, so that applications can take advantage of the security features. Okay. So, we will start with the transport layer security first. So, at the transport layer we talk about two set of protocols, one called the secure sockets layer or SSL and the transport layer security which is TLS. So, we have two protocols here, SSL and TLS that we have. So, what these two protocols endeavor to do is answer the following questions, that is, how can we add security services to web applications, email, remote login, file transfer, etc. Now, all these are applications which may require secure data transfer. So, since these are application layer protocols, applications and they run on top of the transport layer, if you can provide security at the transport layer, it automatically means that you have provided security to all these different applications. So, how is it that is done? So, what these two protocols do is, both SSL and TLS, they provide security services through a standard API. Now, API is Application Programmers Interface, which is basically a set of libraries on top of TCP. Okay. So, these applications, if they require secure services, will make use of this standard set of API and will obtain or will achieve the secure communication that they need. Okay. So, if we look at how this is typically done, so you have the normal network as such, IP, TCP on top of that. You would typically have application layer sitting on top of TCP. Now, with security brought in, you have this SSL or TLS layer coming in between your TCP and the application layer. Okay. So, to the application it looks like a transport layer. Okay. Only thing is it will connect now using an API called an SSL connect and it will accept using SSL accept instead of accepting from TCP as such, it would now use a special function called SSL connect or SSL accept, read, write and so on. Okay. And then the application makes use of the security features that are provided by this particular protocol, by this layer as such, and you have this SSL and TLS protocols which are the end to end protocols that we have. Okay. So, if you look at the TLS, the transport layer security protocol, it is a standard which is based on the secure sockets layer. Okay. So, we focus more on the TLS, just take it for now that it is based on this SSL mechanism, and the TLS as such has two sets of protocols. Okay. So, it has a handshake protocol which is used to negotiate a session, and then it has a record protocol which is used for data transfer, that is for the application communication. So, you first need to have a handshake session followed by the record protocol. For the handshake, that is when you need to negotiate the various parameters that are associated with the security, we use the handshake protocol. Once the session is established, then the record protocol is used for the actual data transfer. Okay. So, what does the handshake basically involve? This will take care of authentication and it may include exchange of certificates. Now, certificates are typically, we talk about key certificates that are obtained from a authorized authority, a centralized authority, and these are used to say that, say for instance, when you are using public keys that have to be used by various users, public keys are published and again by certain authorities, and you need to have a certificate from that authority. So, we use so certificates have to be exchanged in order to make sure that you make your public key and other information available to each other. So, the handshake involves that process of authentication, which also may include exchange of certificates, and you would also negotiate various session related parameters during this handshake. Similarly, session keys are exchanged during this handshake process. Okay. Then establishing of a session ID is also done during the handshake process. So, handshake will take care of these 4 parameters: authentication, which includes exchange of certificates, negotiation of session parameters, exchanging of session keys, establishing a session ID. Okay. And the record protocol, that is the one which is used for data transfer, that specifies the format of data including encryption, compression and so on, and optional use of security hash. For instance, we may use MD5 protocol for the as a hash function for message authentication and so on. So, these are things that are specified by the record protocol. Okay. If you look at the authentication sequence that is followed by TLS, now a certificate we said is exchanged, and a certificate normally shows that the entity's public key is legitimate, but it does not authenticate the server. Okay. So, in order to do the authentication, SSL TLS uses the following sequence. Now, I say SSL/TLS because the same thing is followed in both SSL as well as in TLS. So, if you look at the authentication sequence, it will go like this. We have a client talking to an application client talking to a server using the TLS authentication sequence. So, what the client first does is it sends a client hello message, okay, and in response to that the server sends back a server hello. So, this is used to establish protocol version, session ID, ciphers, compression method and for exchange of any random numbers. Okay. So, then the server sends a server certificate, right, and also sends any other request, a certificate request from asking the client to send its certificate. So, the server sends the certificate and responds to the client's challenge, okay, to verify its identity, and then it says server hello done, which means that the server has completed its part of the hello. Okay. So, server's hello starts with the server hello message followed by the server certificate followed by a request for the certificate from the client, and then it sends a server hello done. Okay. Now, this certificate request is an optional feature, it may or may not exist. Now, in response to this, the client then would send the client certificate, that is, if the server had asked for a certificate, then the client sends the client certificate. Note that these two are in blue indicating that they are optional. Okay. So, client sends his certificate and responds to the server's challenge, so verifies the ID and then sends a change cipher spec message and then says finished handshake, that is, the client side has finished the handshake. Now, normally we talk about a hello hello message exchange as the handshake. So, it finishes the handshake with a finished handshake message. Okay. Now, change cipher spec again, a server responds to the change cipher spec. Now, this change cipher spec is basically a message which indicates that specifications of the cipher are being changed, that is, you are changing to another cipher using an agreed upon session key. Okay, all this is done. Then that finishes the handshake from the server side as well. So, server also sends back the changed cipher information and then finishes the handshake. Okay. So, this is the handshake process that is involved for authentication between the client and the server. So, you can see that the client initiates the hello process, server responds to it, asks for more information, then the client responds to it, asks for change in cipher specification and so on, server again responds and then finishes the handshake. Okay. So, this is the entire authentication sequence that is used by the TLS protocol. Okay. And if you look at applications which are using TLS, they obviously use a different port number other than the normal TCP port that they would use. We have the secure shell which uses the port number 22 which uses SSL directly. Then you have HTTPS which all use TLS, which is now HTTPS stands for the HTTP protocol which is secure. So, HTTPS protocol uses port number 443. Similarly, LDAP-S uses 636. Telnet-S, you have a secure version of Telnet which uses 992. IMAP-S and POP3-S, they use 993 and 995. Okay. TLS also supports session resume to reduce the number of round trips needed to reopen the HTTPS connection. Remember that if you are looking at HTTP, we talk about establishing connections and then sending the data, right. So, what TLS allows us to do, because for every connection that is established, you will have to go through the TLS handshake process. In order to save that time, TLS supports a session resume option, so that the total number of round trip times that are needed to reopen a HTTPS connection is reduced. Okay, that is something that we have. Now, coming to the IP level security, that is security at the network layer. So, we have a protocol called the IPsec protocol. Now, the problem with protocols like SSL and TLS is that they require modification of applications to use the SSL TLS libraries, right. As we just said, a different port number has to be used, so which automatically means that you will have to change your code if you want to make use of the security provided by the TLS protocol. So, we need to make changes to the application so that they can use the SSL and TLS libraries. Okay. IPsec on the other hand is an easier option because you are providing security at the IP layer. So, applications need not know about the security services. Okay. So, that is you are providing at a layer which is lower than the transport layer. So, all applications without any change in the application code will be able to make use of the security features that are provided. So, that is what IPsec tries to do. Okay. So, how do we use IPsec? There are different ways in which IPsec can be used. There is a port based mechanism for using IPsec, that is secure all communications for a given application. Okay. That is, for instance, I could use IPsec for HTTP and SMTP and use IP for other ports. So, IPsec allows you to selectively use it based on the ports. That is, for certain ports it provides security, and for certain other ports you need not, if you do not want security, you can use the plain old IP protocol without the security feature. Okay. So, this is one way in which you could use IPsec. Second is we use it on a host basis, that is all traffic between two hosts can be done in a secure manner. Okay. That is to say, between two hosts, IPsec for all traffic between these two servers that you have. Suppose for instance, I am using mail, okay, mail and an LDAP server I have, all the traffic that originates between two hosts could be sent using the IPsec protocol. So, all the traffic would be secure. Okay. The third option we have is a network based connection, that is you secure all traffic between two networks. Okay. In this case, we use what is called as the IP tunneling feature. We will take a look at this shortly, in which IP is sent inside an IPsec packet. Okay. We will take a look at what this means, but this allows you to secure the complete traffic that you have between two different networks. Okay. This is another possibility. So, IPsec can be used to provide security at these three different levels. So, we have the choice of going for choosing the level of security that is provided by IPsec. So, here we are talking about I have an office A and an office B here, right. This is the network based security that we talked about. So, complete between these two networks, complete security is provided by the IPsec protocol. Now, so if you look at where the IPsec lies in our layered model, so we talk about, so if you look at TLS, right, I am just comparing TLS based security and IP security. In TLS based security, you have application, then you have the secure transport layer, then TCP, IP and the network, right. Here you have application, TCP, UDP or other transport layer protocols, and then you have IPsec, then you have the IP, that is it now lies between IP and TCP or UDP, the transport layer and the IP protocol. Okay. So, which is why you can see that this interface of the application with the layer below it need not change. So, applications can continue to run without any change, right, but you could it is only this interface that will have to be changed appropriately. So, what is the scope of this IPsec? How does IPsec define its scope? Okay. It does it with the help of the following features. It has what is called as an authentication header, and then it has something called an encapsulated security payload. Authentication header is shortened to AH, encapsulated security payload is normally shortened to ESP, and then it gives you a key exchange mechanism defined by the following RFCs 2401, 02, 06 and 08. So, these are different RFCs which are used to determine how the authentication, encapsulated security payload and the key exchange operations take place. So, we will take a look at the details of these authentication header, ESP and so on after a short break. Welcome back after the break. We were just talking about the IPsec protocol. We said that the IPsec scope is defined in terms of the authentication header and the encapsulated security payload. So, we now take a look at the details of this authentication header. Okay. So, if you look at the authentication header of the IPsec protocol, now this is the one which provides authentication and data integrity. Secure checksum is what it provides for this purpose. The IP protocol number 51 identifies the IPsec AH, that is we said that IPsec AH the IPsec protocol runs on top of the IP protocol. So, the protocol field in the IP packet would give a value of 51 and that would point to the IPsec authentication header. So, if you look at the authentication header, this is how it looks like. So, note that this IPsec packet will be carried in an IP header, right. So, if you look at this IPsec AH, the authentication header part, so that will have the following information. It has a next header, then it has a payload length, and then it has what are called as security parameters index or SPI as it is referred to, a sequence number followed by the authentication data which is the message digest. Okay. So, the security parameters index, sequence number, authentication data, all these are the fields which provide the information required for the authentication portion. Okay. So, this is what we have in the authentication header format. Now, if you look at the encapsulating security payload, the ESP payload is responsible for data integrity, host authentication and optional encryption of data. So, here again the IP protocol 50 is used to identify the presence of an IPsec ESP frame. So, we have two different protocol numbers to identify whether it is an AH frame or whether it is a ESP frame that is being carried. Now, if you look at the details of the ESP payload, you can see that most of the security related information is here. So, you have the ESP header which consists of an SPI and a sequence number. Okay. SPI stands for security parameters index, right. This security parameters index is already is the one that is used to identify the security association. We will just look at what we are talking about. Okay. So, then you have the encapsulated payload, for example, this could be the TCP frame, and then there is an ESP trailer. There is the ESP packet consists of a header, the payload and the trailer. Okay. So, if you look at the ESP trailer, this consists of a padding and a pad length, next header field, and then you have an authentication data, right. The size of this is variable. So, you have an SPI sequence number specified and then you have authentication data. Okay. So, typically the way the IPsec protocol expects you to use this feature is like this. Now, the sender and the receiver save information about the security scheme, that is the encryption algorithm to be used, keys, authorization, lifetime and so on. This is saved in a security association on the host. We use a term called security association which consists of all these parameters. Okay. So, this is saved on the host and then the SPI, the security parameters index, is used to identify the SA for a given packet. So, for different packets you could use different security associations. So, which association is being used is identified by means of this security parameters index. So, SPI identifies the SA for a given packet. So, we look at what the security association actually does for us. To understand it in simple terms, it basically provides a one-way relationship between a sender and a receiver. Okay. For two-way, you need to have two associations. Okay. That is, from A to B if you have a security association, B to A you need to have another security association. So, for one-way relationship is identified by one security association. Okay. So, there are three SA identification parameters which are security parameter index, the IP destination address and the security protocol identifier. These three put together identify the security association field. Okay. So, if you look at the SA parameters, the security association parameters, there are a number of parameters that it uses. Okay. We need not understand the details of each of them, but we need to get an idea of what it contains. Okay. It has a sequence number counter. Now, that is one simple thing to understand. It has a sequence number counter which indicates the sequence number for the particular transmission, a sequence counter overflow field, and then it has something called anti-reply windows, authentication header information, ESP information, lifetime of the association, and then the mode in which the IPsec protocol is to work, tunnel mode, transport mode or wildcard mode. Now, there are two different modes in which IPsec can be used, tunnel mode or transport mode. We will just take a look at that. But these are the different parameters which would be present in a security association. So, using these parameters, the two sides determine how the entire security protocol is to be implemented. It also has the path MTU, that is the maximum transfer unit for the path. Okay. Remember this term from our discussion on terms of the transport layer and the layers that we had below that. Okay. Now, so if you look at the scope of the ESP, there are two possibilities that we said, right? We have a transport mode of operation and a tunnel mode of operation. So, let us look at how ESP works in both these modes of operation. So, let us look at this. So, we have this original IP packet. Now, what does the original IP packet consist of? It will have the IP header, TCP and the data, right. This is what you would normally have in the original IP packet. If I were to use it in a transport mode of operation, then what happens is, you have the original IP header, right, and then what is there inside the IP header is your IPsec packet. Now, the IPsec packet consists of an ESP header, then the data which is carried inside it, right, which may consist of the TCP and the data plus a ESP trailer. Now, the ESP trailer, the data and the TCP, that is whatever comes from TCP along with the data and the trailer that is added to it are encrypted, right, and this is embedded between an ESP header and an ESP authentication field. Now, so the purpose of this ESP authentication field is to ensure that this ESP information is authenticated. So, encryption and authentication is provided in what is referred to as the transport mode of operation. Okay. So, here the original, that is, you have the entire ESP packet carried as a packet in the IP as a part of the IP data, IPv4 protocol. Now, the next mode is the tunnel mode of operation. Here what is done is, you have the original IP header, TCP and data, right. So, that you add the ESP header and trailer, that whole thing is encrypted and that is carried inside a new IP header, right. So, this original IP header is no longer available for others to see. So, the original IP header and whatever data that came in, right, the original IP header plus TCP plus data, this entire thing is now carried as an encrypted part in an IPsec packet. So, you have encryption for this entire data including the original IP header, and then you have the ESP header and authentication part added, so that that is authenticated and this is carried under a new IP header. So, we have a new IP packet that is used. Okay. So, this is referred to as a tunneling mode of operation. It is called tunneling because an IP packet which is encrypted is now, which is an IPsec packet, is carried inside another IP packet. So, we refer to this as the tunneling mode of operation. Okay. So, if we compare these two, transport and tunnel modes of operation, in the transport mode you provide protection for the upper layer protocols and it extends to the payload of the IP packet and it is end to end between two hosts. Okay. If you look at the tunnel mode of operation, now this provides protection for the IP packet, right. Note that in that case we are only providing protection for the upper layer protocols. Here you provide protection for the IP packet as well, because the entire packet is treated as payload for an outer IP packet. So, no routers will examine the inner packet. So, nobody will know what is the IP information which is inside your packet. So, no routers examine the inner packet and you could have different source and destination addresses, and so this can be implemented at the firewall. Okay. So, tunnel mode is something which is very useful because it provides total security for the communication that is taking place between two ends. Okay. One of the uses of IPsec, especially in this tunnel mode of operation, is to set up virtual private networks. VPNs can be set up using the IPsec protocol. So, let us look at how that is done. So, as I said, one application of IPsec is to create an IPsec tunnel between networks using security gateways. The administrator defines the IPsec parameters for all communications between designated routers, that is authentication, encryption, etc. They are all defined by the administrator, and so between two different networks using a security gateway, a tunnel is set up, an IPsec tunnel is set up, and we are able to provide what is called as a virtual private network. So, all traffic between these gateways will use the IPsec protocol, okay, and you do not have to configure each of the end hosts for IPsec. It is only the gateways that need to be configured with IPsec. Okay. So, this is typically what you would have. You are using basically, now look at what we understand by a virtual private network. This means that actually you are using the internet for communication, but virtually it is being used like a private network, which means nobody inside the internet would really know who is talking to whom, which node is talking to another node. You can't look at the IP addresses and determine that it is this particular machine talking to this particular machine. Okay. So, we are setting a virtual private network on the internet. Okay. So, let us look at how that is done. Okay. So, you have a private network here and then I have my security gateway here. Now, the security gateway is implementing IPsec in the tunnel mode. So, it takes all data coming in from this private network, encrypts all the data, tunnels it into a new IP packet and sends it to this destination address. Okay. So, the IPsec is used between the company's gateways, okay, between the gateways, and if it is for some other destination, if you are going to send data, there we use clear communication. Okay. But if it is between the company's gateways, because it is from here to here that I want a private network. So, all this data going from here to here is encrypted using the IPsec protocol. So, the other people here, if it is meant for this gateway, they only know it is going to the gateway, they do not know to which node in the network it is going to. So, they have provided a kind of secure communication between this node, some node in this private network and some node in this private network through the internet, but nobody in the internet really knows who is communicating to whom. So, you are able to set up a virtual private network and is done with the help of the IPsec protocol running at these gateways. So, to summarize, so what we have looked at today are the following. We have looked at details of the transport layer security protocol. So, we have looked at TLS and the SSL, TLS/SSL protocols. We looked at how there are two phases of operation in the TLS and SSL protocols. We have also looked at network layer security. We have looked at details of the IPsec protocol. We have taken a look at the authentication header and encapsulated security payload header of the IPsec protocol. We have looked at the two modes of operation, the transport mode of operation and the tunnel mode of operation, and we have also seen how the tunnel mode of operation can be used to set up a virtual private network. Set of questions for you to review the matter that has been covered in today's session. Question number 1. What are the protocols available at the transport layer for security? Question number 2. What functions are provided by the TLS protocol? Question number 3. What is the advantage of IP layer providing security? Question number 4. What is the tunnel mode of operation? Question number 5. How is a VPN set up using IPsec? Thank you.